On the test tomorrow, there will be one piecewise defined function. It'll be similar to this one in that it'll have two pieces to it. In this case, f of x is defined as 1/2 x plus 1 if x is greater than or equal to 0. That means that when x is greater than or equal to 0, it's going to look like the line y equals 1/2 x plus 1. Well, that's a line, and it's got a y-intercept of 1 and a slope of 1/2. So we go up 1 and over 2 to find our next point, and then extend it. But the thing is, we don't want the entire line. We only want that line for which x is greater than or equal to 0. This is where x is equal to 0. It's greater on the right-hand side, so I'm going to erase all this stuff on the left. Since it can be on this line when x is equal to 0, I'm going to put a dot on this end, and there's the first piece. For the second piece, that's defined as negative x when x is less than 0. So when x is less than 0, it's going to look like the line y equals negative x. Like I said, this is a line as well. It's negative 1x plus 0, so it has a y-intercept of 0 and a slope of negative 1, so down 1 over 1. And that means the line looks like this. Of course, we don't want the whole line. We just want the piece that's less than 0. So this is when x is equal to 0. The right-hand side is when it's greater. The left-hand side is when it's less than. We want the piece that's less than. So I'm going to erase the right-hand side and just keep this half. Now this is only for when x is strictly less than 0, not when it's equal to. So I'm going to put a circle on this end of it. And those are the two pieces of the piecewise defined function.